All right, let's dive in. Today, we are pulling back the curtain on Google's massive big data platform. We're going to explore the exact tools and blueprints that Google literally invented to handle more data than anyone else on the planet. Ready to see how the magic happens?
I mean, just stop and think about that for a second. The scale is almost impossible to wrap your head around. For Google, figuring this out wasn't just some cool engineering problem, it was a matter of survival. And the solution they built for themselves, well, that became the foundation for what we now know as Google Cloud.
So here's how we're going to break it down. First, we'll uncover Google's original secret weapons, the internal tech that started it all. Then, we'll take a tour of their data factory to see how all these tools work together. After that, we'll look at the two main ways you can design your data architecture, and we'll wrap it all up with a killer cheat sheet to make sure it all sticks. Now, here's the thing you have to understand about Google Cloud. It wasn't born in a boardroom as a product to sell. It was forged in the fires of necessity. Google was drowning in a sea of data from search and YouTube, and they had to invent their way out of the problem. It was only much, much later that they decided to offer these incredible tools to the rest of us.
And you can literally trace the family tree right here. Colossus, their internal superpowered file system, became what we now call cloud storage. Borg, their legendary system for running huge applications, was the direct ancestor of Kubernetes. And Dremel, their lightning-fast query engine, is the magic behind BigQuery today. So when you use these services, you're not just using a cloud product. You're using the same battle-tested infrastructure that powers Google itself.
All of this experience led to a really powerful philosophy: serverless. It's a game-changing idea, but it's actually pretty simple. Instead of worrying about buying servers, setting them up, and keeping them running, you just hand your work over to the cloud. You get to focus on what actually matters, your data and your code, not the plumbing underneath. And this analogy? It's perfect. Managing your own servers is exactly like owning a car. You've got the upfront cost, the maintenance, insurance, gas. It's a whole thing. Serverless is like using a taxi app. You just open the app, say where you want to go, and you only pay for that one trip. It's pure utility without all the overhead. Okay, now that we get the why, let's take a look at the what. Let's step inside the data factory. Think of this as a tour of a super advanced smart factory, where each service is a specialized machine designed to do one job really, really well. First up, you've got cloud storage. This is the factory's giant warehouse. You can dump anything in here: structured data, messy data, images, videos, you name it. Next, we have PubSub, which is like the factory's instant messaging system, bringing in a constant, real-time stream of new information. And then there's Dataflow, the smart conveyor belt that's clever enough to process data from both the big warehouse and that fast-moving live stream. Now, every factory has a section with some of its original heavy-duty machinery, right? That's Dataproc. It's the wing designed to run your existing big data jobs that use popular tools like Hadoop and Spark. But the real heart of the modern factory, the super brain of the operation, is BigQuery. Think of it as a super smart accountant who can sift through mountains of data and give you answers in seconds. Of course, you need someone to run the whole show. That's Composer. He's the factory manager, the conductor of the orchestra, making sure every job runs at the right time and in the right order. And finally, my favorite part, you have Vertex AI. This is the factory's R&D scientist, taking all that beautifully processed data and using it to build models that can predict the future. Okay, so we have all these amazing machines in our factory. Now what? How do we actually connect them all together? How do we build the roads and pathways for our data to travel on? Well, that's where we get into data architecture. See, any modern data factory has to deal with two completely different kinds of traffic. On one hand, you have batch data. Think of these as huge truckloads arriving on a set schedule, like your daily sales figures. On the other hand, you have streaming data, a constant flow of small, fast-moving cars, like clicks on a website or real-time sensor readings. And this leads us to two main ways of building our roads. First, there's the Lambda architecture. This is where you build two separate roads, a big, sturdy one for the trucks and a fast, separate one for the cars. It's super reliable and accurate, but now you have two roads to maintain, which can get complicated. The other way is the Kappa architecture. Here, you just build one giant multi-lane superhighway for all the traffic. It's way simpler to manage, but you better make sure that highway is incredibly well engineered to handle everything without causing a traffic jam. Phew, We have covered a ton of ground. So before we wrap up, let's distill all of this down into a simple, memorable cheat sheet so you can walk away with the most important bits locked in your brain. First, to remember the original, secret weapon technologies that started it all, just think of 3 letters: D, B, C. D is for Dremel, the engine that powers BigQuery. B is for Borg, the granddaddy of Kubernetes. And C is for Colossus, the beast that became cloud storage. D, B, C, the tech that built Google.
Okay, next, for the typical journey data takes through our factory, just remember this sequence: S, P, D, B, C, V.
You store it, then use PubSub to bring it in, Dataflow to process it, BigQuery to analyze it, Composer to orchestrate the whole thing, and finally, Vertex AI to get predictive value from it. S, P, D, B, C, V. Your whole pipeline in one handy acronym. And finally, for those 2 main design patterns, just think L versus K. Here's a really easy way to remember this. L is for Lambda. Think of it as the long way, the one with 2 different layers. K is for Kappa. Think of that as the key to simplicity, the awesome way that uses one unified stream for everything. So let's put it all together one last time. Here is your blueprint. You gather your data with PubSub or storage, you process it with Dataflow, you orchestrate everything with Composer, you analyze it all in BigQuery, and then you use Vertex AI to predict the future.
In there you have it. That's the core of Google's big data platform. From its secret origins as an internal tool to a complete data factory you can use today. The very same technology that handles billions of searches and serves up all those YouTube videos, it's right there at your fingertips. So, the only question left is, now that you have the blueprint, what are you gonna build?